problem, we are told that there are two identically charged spheres, each of mass 3 into 10 raised to minus kg, minus 2 kilogram, and they hang in equilibrium as shown. The length of the string L is 0.15 meters and theta is 5 degrees. So let us first complete our figure, and what we have is L is 0.15 meters, right? Both of this is L. The two spheres are identically charged, so let me think that the charge on them is Q and the mass of each sphere is M, and M is given to me as 3 into 10 raised to minus 2 kilogram. And what I want to find out here is what is the magnitude of charge on each square. So I need to find out what my Q is. Okay, so let us think about how we will approach this problem. First of all, when we read this, so the spheres are in equilibrium. So what I will think is that I am going to use a free body diagram because the forces are balanced, spheres are in equilibrium, forces are balanced, and I can use my free body diagram to find out what the forces are acting on the sphere and how they behave. Okay. Secondly, I want to find out the charge and there are forces involved. So obviously I will have to use Coulomb's law. So second will be to use Coulomb's law. And let us see how that pans out. First of all, let us start with the free body diagram. So I have free body diagram. Now note here that both these spheres are identical. The angle here is 5 degree. The charges are the same, mass is the same, length of the string is the same. And so realistically I can just use one of the spheres. Let me pick this sphere to draw the free body diagram, and I have this sphere of charge Q. And let me draw the string. There is a string attached and this is the ceiling, say, and my angle here is 5 degrees. So what are the forces that will act on this? First force is the tension in the string. The tension in the string will act upwards in this direction. Second force that acts is mg, downwards. And third force is Fe, that is the electric force. Now since these both spheres have the same charge, Fe will be a repelling force that will push them outward, and so my Fe will act in this direction. Now if I want to write the equation of equilibrium, what it means that forces in x direction add up to 0 and forces in y direction add up to 0, and that is how the object is in equilibrium. So let me select my axis. For my convenience, I'll select the axis as this, as my x-axis, and this is my y-axis. You can really even select the axis along the string and perpendicular to it, in which case you'll have to resolve Fe and mg, and so I'll just make life easy for me and resolve only one force, that is the tension in the string. And so let us resolve T along my x-axis and T resolved along y-axis is like this. This angle is 5 degrees, so this angle is also 5 degrees, and this is my T sine theta and this is my T cos theta. And so my equation of equilibrium basically becomes, this is positive x direction, negative x direction, so I have T sine theta minus Fe is 0, positive y direction, negative y direction, T cos theta minus mg is equal to 0, and that gives me T sine theta is equal to Fe and T cos theta is equal to mg. Now mg are known, theta is known, Fe and T are unknown. I'm really interested only in Fe, so I will try to get rid of T from the equation, and the way to do that is if I divide these two equations, and that gives me tan theta is equal to Fe over mg, and thus I can find my Fe as mg tan theta. Good. And so I know all the numbers here. This m is 3 into minus 2 kilograms, g is 9.8, tan of 5 degrees. Remember, this is degrees and not radians. And so let me see what that comes to. And my tan of 5 is 0.09. Let me approximate this as 10, and that will give me my Fe as 3 into 0.09, so that is 2.7 into 10 raised to minus 2 newtons, right? And this is the force acting on each sphere. It's the electric force. So far so good, we found out E, and now the next step is obvious, right? Let me use another page for it, is that we have to use Coulomb's law. So let me use another page. I'll copy what my Fe was on this page. So my Fe was minus 2.7 into 10 raised to, let me copy this, Fe was minus 2 points, minus 2.7 into 10 raised to minus 2 Newton was my Fe. So I am on my part B, I am trying to apply Coulomb's law. And what Coulomb's law tells us, that if I have two forces separated by a distance d, let me say that the distance between them is d, then the magnitude of force Fe, and I am concerned only with magnitude because I want to find out the magnitude of charge, so I will not bother about the direction right now, is given by k q upon d square. And let me find out what d will be. So let's see. If I say this distance as a, then I have L, A, and this angle is 5 degrees. And so I can write tan theta is equal to A over L, and substituting the values, I'll get A as 0.15, that is my L, into tan of 5 degrees. And let's see what that comes down to. Tan of 5 degrees is 0.09, and so my A, this will be 135, my A is approximately equal to 0.13 meters. Actually 0.013 meters, right? 0.013 meters. Okay. So let me substitute that in this equation, and let me write this equation for q squared first. So I have my q squared is equal to Fe, magnitude of Fe, into d square over k, where d square is, so this is my A, and so my d is going to be 0.026 meters. Fair enough. And I can get my q squared as 2.7 into 10 raised to minus 2 into 2.6 squared, 0.026 squared over 8.98 into 10 raised to 9. And let me see how to solve that. Let me approximate this to 0.03, and 0.03 squared will give me 9 into 10 raised to minus 4. So that is the value of this. And let me call this as 9. So effectively my q squared comes down to 2.7. Let me keep that. Magnitude of q squared comes down to 2.7 into 10 raised to minus 4 minus 6, and that gives me minus 15. Or I can write this as 0.27 into 10 raised to minus 14. And that's my q squared. And from that, I can get my q as equals to approximately, let me see, 0.5 into 10 raised to minus 7 coulombs. And this is magnitude, and really when I take the square root, this can either be a positive charge or a negative charge. I do not know anything about them, because even if they are positive, they'll repel, even if they are negative, they'll repel. And so the answer is 5 into 10 raised to minus 7 coulombs. And let us recap. What we did here was, first we used the free body diagram to find out the value of forces, and then we used the Coulomb's law to find out the charge on these forces. Okay.